Hello, this is the gas chapter. Yep, it is the gas chapter. Everything in this chapter is going to deal with gases and pressure and equations. So if you like equations, you've definitely got some in this chapter. There's also unit conversions. Units become very important to be paid attention to in this chapter. So you'll notice this particular first page has an awful lot of information, maybe compared to some other chapters. Again, if you like equations, that's good. I want to point out a few boxes. We are going to be working with pressure units, and this is a whole box about pressure units. The pressure that we're going to mostly be spending our time talking about is ATM, but if you'll notice carefully, you've got all kinds of pressure. You can have a kilopascal, a pascal, a bar, a torr, a millimeter mercury, and a PSI. Probably the last one is very familiar to you if you've worked on bicycles or cars. That's what goes in our tire. That's how we measure tire pressure. But that's what this whole section, it's just like a quick reference page for you about pressure units. So it's not equations exactly, it's just the conversions to get to them. Notice that 1 ATM, it's always 1 ATM is equal to, and there's all these different numbers that matches with the unit. There's also a little bit of reminder information over on the right and some maybe new information. You are obviously extremely familiar with Fahrenheit. This is how we measure temperature in the US, and gases are very particular about their temperature. This is the conversion to get a Fahrenheit unit into a Celsius unit. There are some equations in the next chapter that can be done in Celsius. This chapter, it should all be in Kelvin. So if you have a Fahrenheit unit, you actually need to convert it to Celsius and then convert it to Kelvin. You only have to add one number to it to get it into Kelvin. Kelvin's an absolute scale. It goes all the way down to 0, and 0 is like the lowest you can get. So this is the equivalent of 0 degrees Celsius, which is the freezing point of water. It's just a really high number. You also don't tend to see a degree sign with the Kelvin unit. You do see it with the Celsius and the Fahrenheit units. Over here, this is just another reminder you will be dealing with volume because gases, well, depending on the space they're in, they'll spread out to fill out their volume of the container. So whichever of these you're used to using, I've been using this version where you put a 1 by the prefix, and then you have the 1 times 10 to the minus 3rd liters. But if this version makes you happier, either version will work. But again, units they're very important. They have to be in certain things for these equations to work. And so that's a quick reminder how to get things into liters. And then also, if you were to ever need it, we have moles. We've been talking about moles. We learned all about moles in the last chapter. We are continuing discussing moles, and you know that this number here with Avogadro is how many it is equal to. Also, don't forget, and I know you know it, but don't forget the periodic chart. You can figure out how many, or the table, whatever you want to call it. You can figure out how many grams are in 1 mole with those numbers that have decimals on the periodic chart. For example, if we're talking about just a single H atom, there are 1.01 grams of single H atoms in 1 mole of single H atoms. We know that's diatomic, but that's just an example from the periodic chart. So this top section, it's kind of like unit conversion. It's not the equations, except there are a little bit of equations right here as we're looking at temperature. They're not too hard though. Make sure you don't forget the parentheses in this top equation. So the rest of these equations, they're better learned in practice, I think. So if we're like, here's a math problem, try using this equation with it, I think it's learned more easily that way. But all 3 of these in this section are related to each other. And that this one is actually also kind of related. So they all are kind of related. P, and it shows up twice in this equation. P stands for pressure. Both units in this one have to be the same. So they don't have to both be ATMs, but they do both have to be the same unit. Notice there's 2 volume units. This one is the same thing. They both have to be the same unit. And the last one, temperature, has to be in Kelvin. This is a big to-do. Everything you do in this chapter, you need to put that temperature in Kelvin. It'll feel uncomfortable at first, but you're going to have to do it. Because, of course, it's chemistry. Not every problem is going to have the units in the right units. So you might get Celsius in an equation and Kelvin in another equation. And then just a few other little notes. You'll notice that all of these are kind of spelled out to the right. So this one also has a pressure, but this one has to have a unit that matches the R value that you use. The R value we're going to have you guys use will make your pressure unit be ATMs. Notice that we have a V, so R volume. Again, they need to match R, and the R unit we're going to use will make it so that volume is in liters. Then we have N is moles. That is not new. You've seen N used as moles before. And then we've got our temperature. This R is a constant. You'll see it in a second. Just want to point out, these lower equations are kind of variations on the same. Notice we still have the same temperature. They've all got to be in Kelvin. We still have the same pressure units right here. They need to be in ATMs. And then there's something that's a little bit different. They both have the R right there. There's the R. They both have R. But this one has this and this. That's different. And then this one has this and this. It actually also has the volume over here. So we've already talked about that one. This right here, that's the molar mass. That's what you get off the periodic chart. So that's not too bad. Molar mass from the periodic chart. So that really, it's not bad. You can grab that number whenever you need it. And then the little m right there, that one, the little m, this represents mass in grams. And again, this is a reference page. I don't expect you to be getting all of this all at once, but I'm just kind of giving a quick overview. And yes, there are definitely problems that will be helping you practice and knowing how to use these equations. This right here represents density over here. The units to this have got to be that one. And this little section is not supposed to be in here, so erase that little section. Notice that this one also has the molar mass. See, they both have that molar mass. Molar mass. Again, it's just the number from the periodic chart. So the big lead up, what is R? Here's our R value right here. And notice these units over here. This tells us what all the other variables that show up in the equation, it tells us what their unit should be. So a liter, that's a type of volume. So if there is a V in the equation that has an R, it better be in liters. ATM, that's a pressure unit. K, Kelvin, that's a temperature unit. And moles, we know moles, that's in. As a little note, if you go searching for R, you may find R's like this. And those R's are very valid and they are used around the world. Just note that you will have to then convert your volume to a cubic unit and your pressure to a Pascal, or your pressure to a torr. So these tend to be used in areas that prefer that kind of a unit for those like a meter, a cubic meter right here. You know, there are some areas of the world where that's what they use. They don't use liters and as much. And then the torr, again, that's going to be where the preference is given for torr. Or maybe it's like traditional that these problems in those areas of the world are worked in torr. But this is the one we are going to work everything in. The lower section we're going to come back to after we finish the first part of the gas chapter.